Hi everyone. Welcome to this week's edition of CamLogic's Tech Tuesday. My name is Rob Carver and I'm an applications engineer at CamLogic. Tech Tuesday is our free weekly 30-minute tips and tricks webinar, and today's topic is exporting a tool assembly. But first, let's familiarize everyone with CamLogic. CamLogic has been in the CAD/CAM CAE space for over 35 years. The company was established 16 years ago, initially focused on CAM, servicing mainly the tool and die shops in the area. As the market has evolved, CamLogic has evolved. Interestingly, working our way backward from manufacturing to the conception of the idea or the design. Because we started toward the end of the process and worked our way to the beginning, CamLogic has the fundamental knowledge of what it takes to what has to be done to assure that each step of the process will result in a product that will actually work or fit into the next phase of development. CamLogic has chosen to represent software and tools that enable our customers to fulfill the full cycle of product development. We consider ourselves integrators and partners for our customers, not just resellers. CamLogic employs a three-legged stool strategy. We partner with Siemens, offering the complete integrated Siemens portfolio for design, machining, analysis, and data storage and retrieval. We partner with 3D Systems for 3D printing and rapid prototyping, and Steinbeckler white and blue light scanners, and Creaform for 3D scanning for inspection and quality. Now you've heard a bit about CamLogic, let's move on to today's topic. Creating and exporting a tool assembly. Normal CAM operations don't require a tool assembly to be exported to the tool library. As many of you already know, you'll see the tool that you've created in the parametric edits. This would be used more in a machine simulation. However, even simulation doesn't require a tool assembly, as you well know. However, you may want to do this if you're trying to create a tool library or maybe a new tool system, if you will, with your company, and you're going to use tool assemblies and PMI data rather than relying on spreadsheets or 2D drawings to build the tool up for your tool preset people. You could have actual 3D models that will run in simulation, ensuring that the tool design, as designed, will do the job that you want it to do. You have to remember that collision checking is still done by the parametric inputs and not the solid model. So the inputs have to correspond to the solid model. And it also this is for systems of version 7.5 or later. Today we're going to focus on how to create a tool assembly with the correct file structure and coordinate systems, enter the corresponding parametric data, and then export the tool assembly to the tool library. So let's see how this might work. So first off, basically the way I start is I start out, let's go look at our assembly navigator to begin with. I've got a tool assembly here. So far it's not really an assembly, but I just have these solid bodies in here, but this is going to eventually represent my cutting tool, and I've got it named. You have to give it a unique name. So your assembly number, I'm going to say, okay, I'm going to start building my tool assembly, my tool library, and I'm going to have CL tool. I've seen some systems where they have FMS numbers, they have all different kinds of number designations. So we're going to start out here with CL_tool, and then here's my unique identifier. Okay. So these tools, these solid bodies is going to represent my cutting end, my tool length. Basically, this is going to represent what you see in the parameters, the parametric inputs for the tool menu. This is my shank. Okay. So the first thing I want to do, I want to create a new component and I'm going to call it CL underscore tool 1x4. Is that what I'm going to call it? Yeah, I got you can get a little bit more descriptive in there. You know, if you want it to be a carbide part, maybe you want to give some designation that's okay. We're going to call this an end mill. So that's going to be my tool. Okay, and make sure I save it in the appropriate library. And here's my tool models. Okay. So now I say okay. I'm going to add these 4 parts. Delete my original objects because I don't need them anymore. Okay. And so now I see this is my first part of my assembly. So you're going to have a part in here that represents the cutting tool. Okay. Now the second thing you want to do, I'm going to add a component. I've got an HSK holder modeled up here. Okay. I'm going to bring it in by constraints. So I'm going to have my touch a line here. So I'm going to touch that one to that one. And then the next thing I'm going to do is fix a distance from here to here of 2 inches. Okay. And bring that in like that. Okay. So now I've basically got my solid tool assembly here. Okay. So go ahead and save that. Okay. And so let's take a quick look at our assembly structure. Okay. We have a part file or an assembly top level file that doesn't have any solid objects in it of its own. It only contains two assembly structures, one representing the cutter, the other representing the holder. Okay, so this is the file structure that you're going to want when you get done with this. Also, I started out creating this on my absolute coordinate system. So everything is relative to my absolute coordinate system. I find that it's just a little bit more convenient doing it that way. Okay. So the next thing we want to do, go into manufacturing. Okay, CAM general, mill planer, that's fine. I'm going to go into my machine tool view and I'm going to insert a tool. Okay, in this case it's going to be the mill, and I'm going to name it the same thing as my assembly mill CL tool 2345. Okay. And now here you want to start entering in your parametric data that's going to correspond to your tool. Okay. So it's a 1-inch diameter. I've got my lower radius of 30 thousandths. Okay. My flute length in this case is going to be 1.5 inches. Okay. Was it 1.5 inches? Yep, 1.5 inches. Total length is going to be 1.75 inches. Okay, I'm going to say that it's a 4-flute tool. I'm going to make it a inserted end mill for my material. And again, I'll give it a descriptor of my unique number, my unique assembly number. Okay. Here you can put in your offset number and offset register if you want. Okay. I'll go ahead and define my shank. My shank's going to be 1 inch in diameter. In this case, it's going to be 2.25 long. No taper length. Okay. And we're going to go ahead and define my holder too. All right. So my lower distance on this is going to be 2 inches. Make sure, yep, I did it again. Double decimal points. 0.25 and 2.5. All right. And we should be seeing that. Okay, you see this up here where it's actually up here? That's because down here in this tool insertion point, we want to make sure we put in the offset. This corresponds with my 2-inch distance here that I put in for my my constraints. Okay, so you see how that brings that down here. Now this is real important because this is what your collision is going to be, your tool collision and checking is going to be based on, not on the solid body itself. Okay, so we'll add another length here, another section. Okay, there's for my solid body. Now, I've seen situations where you actually hit this section here, so I'd want to make sure that I have that portion parameterized as well. Okay, 1.14, 3.934. Okay, and okay, see how this is sticking up here? I made a mistake back here. Instead of being a full 3 inches, should be 2 3/4 because it's an incremental. So this section here was a 1/4 inch. This section here for a 3-inch total, obviously, should have been 2 3/4. So there we have our turning turning solid or rotating solid, I should say. Okay. So now what we want to do, that's all the parameter entries. We go back to the tool. Okay, back to the tool tab, I should say. Okay, now we come down here to the library. And again, I'm gonna use my unique identifier. And click Export Tool Part File. Okay. Now I have to specify my mounting points. Okay. This is for the junction mounting inside your machine. Okay. And make sure that I've got everything assembled there. Why isn't it giving it to me? Edge. All right, hang on 1 second. Entire assembly, make sure that's selected. Now I should get it. There we go. That's better. Okay. Oop, I still didn't get it. Doggone it. All right, let's try this again. Okay, hang on just 1 second. Tire assembly, no selection filter. Okay. And we want to make sure, now it's up there, we want to make sure that our x-axis is aligned with the center line of the spindle, okay? Now we'll do the same with the tooltip, okay? And again, want to make sure the x-axis is aligned with the center line of the spindle. This is the tooltip, okay? Now we also need to ensure that we select the cutting portion of the tool. So I'm going to select this solid, okay? And now I export the tool to the library. I'm going to call it an end mill indexable. Hit OK. Holding systems, I don't have anything in here for HSK, so I'm just going to go with none. All right, and we should get a note here saying that CL Tool 2345 was created in the English Tool Library with a corresponding holder created in the English Holder Library. Tool kinematics were created and the part file was saved. So this actually copied this holder assembly into our tool library for us, okay? So we say OK and save. All right, now if I've done everything correctly, and this is the real test. All right, we'll see if I've already done this with another tool, so let's see what it should look like. And we'll go into the tool path, simulate, show 3D material removal. So here's the tool I'd previously done, okay? I can speed that up a little bit. Now granted it's not spinning, but it does look cool having that in there. I mean, if for nothing else, this looks cool when you're running your simulations. Okay? So let's see if I created the other tool correctly. We'll go in and create a new, retrieve it from the library. Let's go into milling, mill indexable. Okay. I don't want that there. I want to search for 1-inch diameter tools. And here's 2345 that we just created. Okay. Let's generate. Okay. If I go back and verify it, okay, here's my Oops, that was pretty quick. Here's my parametric representation, okay? So now if I go back in to my toolpath and simulate, there we go. I must have done it correctly. So now you can use this. Now you can use these in your tools. You've got a solid body or a solid model that you can dimension and hand off to your tool preset people. This is a record. You can use this as a three-dimensional record of your tools that you're using. And I mean the applications for this, I think, are go beyond, you know, just using spreadsheets and 2D drawings. Okay. So that's pretty much all I have for demonstration. So I'll return to my PowerPoint. And as with anything, you know, this is kind of you don't see this very often. At least I haven't seen it very often. And so going, you know, with this in mind, we can't really emphasize enough the importance of training to get the most out of today's technology. It's well documented that training helps improve the speed of use. It increases the efficiency, provides faster problem resolution, and leads to fewer support calls, all of which positively affect company productivity, the return on your investment, and the bottom line. At CamLogic, we offer a wide variety of hands-on, instruction-intensive courses for users at every level. Training is available at the on-site location of your choice or at one of our training labs located throughout the Midwest. For more information or to register, please visit our website. Today's webinar can be found on YouTube, usually within 24 hours of the broadcast. Check out CamLogic on YouTube for past webinars as well. Thank you for joining us today. If you have any questions, please feel free to email me or call me at any time. Be sure to visit our website at www.camlogic.com. We can also be found on LinkedIn, Blogger, Facebook, YouTube, and Twitter. Our new help desk number is 855-955-0900. This concludes today's edition of Tech Tuesday. Thanks again for tuning in and have a great day.